are joined by Professor Kevin Warwick from the University of Coventry to talk to us about artificial intelligence and the fabled Turing Test. Let's start by asking you a very simple question maybe, or with maybe a complicated answer. What do you do?
Well, I research into AI, but also implant technology, linking humans and technology together. And it can be quite scary because the future is, on the one hand, quite positive. You can see how things like AI can help people in the future, but you can also see how there can be dangers ahead if we don't deal with it in a good way.
Can you tell us what is the Turing Test?
But essentially what it is, what Turing set up, was a test whereby you as an interrogator are looking at a computer screen, and behind half of the computer screen there is a human, and behind the other half there is a machine, an AI system. And what that machine is trying to do is to fool you into thinking it's more human than the human that it's competing against. And what he predicted, this was back in the 1950s when there were not computers, anything really. And he said by the turn of the century, then machines would be able to fool more than 30% of the interrogators. He called it the imitation game. And it was set up as a game with a machine trying to fool you into thinking it was more human. Not that it just that it was human, but it was more human than the human. The interrogators are all sorts of people. And that makes it really interesting because you get some people who are very much technologically, that they've learned all about it. They're computer science professors maybe or whatever. And then you get other people who have never used a computer in their life before. So it's a really wide range. It's the sort of typical person that is the machine is trying to fool, not some clever clogs. There's no specific topics. As an interrogator, you can ask anything of both the human and the machine, and you can talk to the two entities in the same sort of way or differently. It's up to you. And very often a person, the interrogator, will find one of the pair that they're talking to being quite an interesting entity. I'd say person, it might not be a person is the point. And of course the machine is trying to not be perfect, not to give right answers, not to be correct, not to be very clever. And it can throw in errors, letters that are in misspelling words and things like, as humans might do. It's trying to fool the interrogator into thinking that it is the human that's involved. A machine could get past the Turing test by just suddenly remaining silent, taking the Fifth Amendment, if you like, in American language. And then it's a problem for the interrogator because you can ask questions, but you get no response. So is it that something's gone wrong, or is the machine being clever that it's not responding? You need some feedback, you need some response from both the machine and the human for the Turing test to actually work. Some people feel that certain pieces of knowledge are general knowledge. So they'll ask questions assuming there is a known answer. Whereas either the human or the machine could be quite flippant over it, to the extent that I've been involved in the test, lots of practical tests, as a hidden human, as a human that's behind the machine, in being compared to a machine. And I have to say, I've never been classified as a human as yet. So I am officially, by the Turing test, I am a machine.
Did you always be on the trying to fool the judges, or have you also done some judging yourself?
I haven't actually done any judging myself, but I've been involved both analyzing and writing up the results of the transcripts to say these are the results we got, this is what the machines were like, and so on, producing academic papers based on that. But also trying to organize or be part of the organizing team that puts the Turing test together, because that in itself, because being involved with it, I would say it perhaps, but that in itself is quite difficult because you want a whole variety of people. And if you're trying to get people, if you were to advertise and say, we want people for the Turing test, what you tend to get are people that are already interested in the Turing test. They are computer scientists or technical boffins or whatever you might like to call them. You don't tend to get bus drivers and librarians and people from the fish and chip shop or something like that. So what you've got to try and do is to get a whole range of people and different ages, because interestingly, one ploy of a machine, it's good for the machine to be a character, not just to be a blasé machine, but to be a person. But remember, they're trying to be human, and humans are themselves. They're a character in themselves.
So would you say that it's more about how good the programmers are at creating something that can interact like a human?
Yeah, completely, exactly what you're saying. I think it's just looking at communication, and we perhaps learn more in terms of communication in humans than we do about communication in machines.
What else are its limits? We've touched a little bit about the fact that it's not measuring intelligence at all. What else do you feel that is a little bit restrictive?
Oh, well, I think the whole lot, it is just a communication exercise. So that's it. That's it, really. I think it is a particular aspect of artificial intelligence is communication. I do think for human intelligence, communication is an important part of that, both in terms of how we communicate generally, how we communicate with other people, and so on. So it is an important part, and then learning languages and so on and so forth. But in terms of artificial intelligence, it is, again, just one aspect, and doesn't tell us too much about other aspects. So it's a very precise element, and certainly to say because something passes the Turing test or doesn't, whatever, it's got human-like intelligence or human level intelligence. It's nothing like that at all. Turing never said anything like that, and I can't imagine that he would do.
Do you think we are at a point where an existing AI, could fool like 100% of the judges?
Ooh, I think that would be very difficult to get to. Once you get up to the sort of 50% mark, I mean, 30% I see in a practical sense is quite a high figure to achieve, a difficult figure to achieve anyway. Remembering what the machine is doing is competing against another human to be the most human, but the human is just being themselves. They're not effectively computer, they're just got to be regular person. So to actually achieve 100% is not out of the question, let's put it that way. But it would need to be a clever clogs and, a big knowledge base. I mean, it would be difficult. It would be more from a statistical point of view.
Do you think even if there is a way to create a more stringent test to differentiate between a human and an AI?
Yeah, it's a difficult one because what Turing did was include everybody. So some people who have come up with what are perceived to be better tests in different ways. I mean, first point is that the Turing test is just a 5-minute test. So what Hugh Loebner organized a lot of Turing-like tests, but he very rapidly made it a 20 or 25-minute test rather than a 5-minute test. And that makes it very, very difficult if you, at the moment even, if you're comparing humans with a machine, but over a 25-minute, that's actually a long time to communicate. And so the time is one issue, timing is one issue. I think as well, once you bring in certain types of questions and keep on, that can long term help the machine if the machine is constructed around those certain types of questions, because a typical human may not be familiar with a particular field, so they could have very limited knowledge. But if, and I know this is the type of question to ask, and this will out the machine, but then it's something that a human can't answer at all. And the whole point of the Turing test is it's not just a machine answering questions, it's a machine answering similar questions to a human. And then it becomes very difficult because you're looking at a whole range of humans, different backgrounds, potentially different nationalities, different experiences, different levels of, if it's in English, levels of English, but it could be in other languages and so on. So you're looking at an extremely wide range that a machine is looking to compete against. Yes, you can come up with better tests, but how general those tests are is a big question. Turing did to try and explain what the test was about. He said, well, before thinking about the machine, you are looking at a screen, and behind half of the screen is a man, and behind the other half of the screen is a woman, and you then have to converse with the two and decide which is the man and which is the woman. So he was doing a sort of a prelude or a parable of the Turing test for people to try and understand. When he then said, well, okay, now let's take the woman away and now we'll put a machine. Then he described what the Turing test was so that people could, because in the early 1950s, there were not computers for them to consider how we can consider now artificial intelligence systems communicating and the Turing test as we know it now. But so it's really good looking back at what Turing was saying. Turing himself stuttered quite a lot. And John Westcott had said it didn't bother him when he was talking, he just kept going. And you followed the technology, so it didn't matter. But if you were doing a conversation system where, like we are now, conversing and recording and so on, then obviously the stuttering, I don't know whether you design a machine that stuttered or anything, or had problems in the way they converse. But of course, the stuttering disappears as soon as you type something in, as soon as it's a text-based system. I guess you could put the stuttering in there, but it wouldn't be what you expect from a human at all.
What are there similar tests or completely different tests, but tests to challenge AIs on different aspects beyond the Turing tests?
Well, with AI, it's very difficult. Communication, we can look at as something that is similar, humans, machines, and so on. But when it comes to sensing the outside world, of course, human sensory input can be quite different to machine sensory input. Typical robot systems, for example, can sense ultrasonically, ultraviolet, X-ray, all sorts of different ways that humans don't sense. But they can be given vision systems, they can be given audio, they can be given those, but they could be different frequencies and so on. So we can do tests, but they would potentially be considerably different between humans and machines, humans and AI systems. It's the same in the way that AI operates. AI has distinct advantages over human intelligence, not only the speed of operation, for example, but also, and this is important, the dimensionality. Human brains tend to think, as far as we understand, in terms of 3 dimensions, whereas machine brains can think in hundreds of dimensions. And that is an enormous advantage. So one of my own feelings is, wouldn't it be good if we can have that working for us, which we tend to do when the AI system machine is a tool. rather than having it potentially acting against us, which if we set it off on a task, we got all of those advantages that might not work in our favor. If I could link my brain directly with an artificial intelligence system, so effectively the system, the total system, is partly my brain and partly the artificial intelligence system, could I then start to understand things in more dimensions? I mean, I don't know the answer to that. I would love it if the answer was yes, but it's can we grab hold of the advantages of AI and use them in a much more effective way for humans?
There are, I understand in cybernetics, some new systems that can mimic feelings and can transmit signals, etc. Do you think that is a sort of big stepping stone to what you're saying about connecting to artificial intelligence that can really open up our minds?
Oh, yes, I feel just looking at the sensory input, as you said, cochlear implants that respond over a bigger frequency range, or potentially, I mean, what I've experimented with myself is ultrasonics, like a bat sense. And for the one experiment that I did several years ago now, I had an ultrasonic sensors feeding into my nervous system, which my brain could then learn to recognize. This is electronic pulses that related to ultrasonic signals, which gave me an indication of distance to an object. I mean, that's probably the simplest of all the different senses, but our brains are, even at an older age, our brains are quite adaptive. So we can take on board new information, and taking on board information either extending the sensory range, as you were saying, or bringing in different sensory inputs, I think is quite possible for us. It then becomes a question of which of those, the extensions, is useful, is better, we can employ in a way effectively. What would it mean to the human brain to take in signals like that, or that relate to that, doing it in a safe way? There's a lot of experience that we simply don't have at the moment, but it would be good to find out. So could we extend the senses? We need to experiment.
Yes, and I love that you did an experiment in which you had like sonar like a bat. That is fascinating.
It took several weeks for my brain to tune in to the pulses, for me to learn to recognize the pulses. But then when we did the experiment with the ultrasonics, it was very quick, and it was quite accurate, I have to say. That was accurate, not in the sense of I know that object is 2.36 meters away. So not like that, but in the sense of knowing there's an object that is a distance away, and if it moved slightly towards me or slightly away from me, I could detect that very accurately. So, it is coming towards me, which is going away from me, just with a very slight movement.
That's amazing. And to be honest, with all our senses, we just forget that it took us years to work them out because we were babies. So the fact that in a couple of weeks you can pick up a completely new sense, that is fantastic.
Well, and you wouldn't, I mean, because of evolution, clearly we have diversified from other creatures. You know, we, the other, like bats, do have an ultrasonic sense. So I wonder when evolution created that in bats and didn't create it in humans, or did it create it in humans, or the ability to have that sort of sense? But we'd never sort of taken that on board. It's interesting questions from an evolutionary point of view. Why haven't we got an ultrasonic sense?
Yeah, and it's another big question that I'm sure that hopefully the answer will come at some point. I have a big question for you now, though. Given how quickly AI has grown and changed in recent times. What are your concerns about its applications?
Well, I think where I'm not so concerned, so I'm going to answer the not what wasn't the question first.
Fair
I, I
enough.
think I think in healthcare particularly, there's lots of potential use for AI systems, particularly with complex areas such as the human brain. I think we will be able to understand what's going on a lot more by the use of AI. And the brain operates electrochemically. We tend to look at it more from a chemical point of view. We take drugs. If you've got a headache, you take aspirins or paracetamol. You take chemicals. You don't look at electro. And I think we will have much more electrical type or electronic type of medication with the help of artificial intelligence to say what problems are. So I think there will be great moves over the next few years, particularly to help people in many ways. But where it's dangerous, I think where you're looking at, for example, a military system that has inputs that we are not necessarily fully aware of what is going to trigger this and what is going to trigger that. Particularly if it's an AI system, then it is going to be able to learn. Intelligence, I think, requires learning. So if we say AI, we mean the system can learn. And if it's got different sensory inputs, which can be very simple, then it potentially can learn something which we simply didn't expect at all. And the conclusion could be, we are the bad guys, we're not the good guys. And the system, if it's a military system, could be acting against us rather than for us. So those are my sort of concerns. If we start to see systems acting against the people that are supposed to be controlling them, then I think we've got to, particularly when you feel you cannot switch the system off. If you can switch the system off, then there's no problem. We don't need to talk about it. But if you can't switch the system off, if it's got self-repairing mechanisms or it's designed not to be, to make sure that it can't be switched off, then you're creating problems, I think.
I can see it. But to conclude on a more positive note, you already mentioned AI in healthcare, but if there is one hope for you about the future of AI, what is it?
Oh, can I have two hopes? I
Give me two hopes.
I think in healthcare, seeing neurological problems such as schizophrenia being helped by AI systems, I think we're not far away from seeing that happening, and I would love to see it happen sooner rather than later. There's a lot of people affected by it, and if they could be helped along the way, that would be great. I believe that is possible. Um, the I think the second hope, more long-standing, it is the possibility of joining human brains with machine brains. The whole issue of understanding more dimensions, I think, is critical, because where we are in the universe, we've hardly been anywhere at the moment. We've been to the moon, which is just a short hop away. We've not even been to Mars yet as humans. And I think a big problem with that is traveling there. If we want to get to another solar system, then getting there will take the lifetime, and then you need another lifetime to come back again. It's completely impractical. So there's got to be the possibility of traveling through other dimensions, but we don't understand what those dimensions are. So I think the big wish, the big hope, perhaps it's more long term to say the least, is that we could link with AI systems and understand what multidimensionality is all about, and then perhaps start to travel through the universe as Star Trek showed was possible, rather than as we've seen is possible through spaceships which have just gone to the moon so far.
I completely agree on that hope that we could travel to the universe in a much quicker way. Thank you so much for joining us today, telling us so much about AI and the Turing test. Thank you so much.
Thank you.